what adjustments were made on the Chandrayaan-Three relative to 2 once they figured out why that second mission failed.
Deep within the mysteries of the moon, a discovery by India's Chandrayaan-Three mission has ignited a storm in the world of space exploration. Neil deGrasse Tyson's recent statement suggests that India may have made a significant discovery not previously acknowledged by NASA. This has triggered a lively debate within the scientific community. This revelation may change what we know about the moon and the secrets it holds. But what exactly did India discover on the moon that NASA might have kept hidden? Join us as we unravel how India finally found what NASA was hiding on the moon and what this could mean for the future of space exploration. The revolutionary journey to the moon's surface. In the year 1966, the course of space exploration shifted indelibly with Luna 9, a mission launched by the Soviet Union. This mission stands tall in the chronicles of space conquest for accomplishing the first gentle touchdown on the lunar surface. Luna 9's unprecedented feat not only signified a successful landing, but also gifted humanity with remarkable panoramic vistas of our nearest cosmic companion, the Moon. This spacecraft was no ordinary creation. Its appearance resembled a spherical capsule, a pioneering and strategic design. Weighing merely 19.9 kilograms and measuring 58 centimeters in diameter, Luna 9 was equipped with innovative features. Its uniqueness lies in 4 pedals, designed to serve a dual function. Upon landing, these pedals played a crucial role in stabilizing the craft while revealing its essential instruments. Among its payload were cutting-edge components: a communication radio system, state-of-the-art solid-state radiation detectors, and a pivotal thermal control system. This control system was instrumental in managing temperature fluctuations, ensuring the functionality and longevity of the mission. A significant highlight of Luna 9 was its groundbreaking addition: a television camera mounted on a rotating platform. This revolutionary feature facilitated the capture of breathtaking imagery of the lunar landscape. The images transmitted by Luna 9 were nothing short of mesmerizing. They unveiled a lunar terrain characterized by stark contrasts, a canvas painted with rugged craters juxtaposed against undulating hills. These captivating visuals unveiled uncharted territories devoid of human presence, offering humanity its first glimpses of the lunar surface. The impact of Luna 9's imagery was profound. Its images captivated audiences worldwide. The visuals revealed a lunar topography previously unseen by human eyes. Their allure was such that they swiftly made headlines in prominent media outlets, including the Daily Express newspaper. The images, received by the Jodrell Bank Observatory in England, captured the imagination of people globally, igniting a fervor of interest and curiosity about the enigmatic world beyond Earth. Luna 9's mission extended far beyond the captivating visual captures it offered. Engaging in crucial scientific investigations, the spacecraft meticulously recorded temperature variations on the lunar surface. The meticulous data unveiled stark extremes, from a frigid negative 153 degrees Celsius during the lunar night to a scorching 123 degrees Celsius during the day, shedding light on the moon's near absence of atmosphere. The pressure readings revealed a stark contrast to Earth, measuring less than a billionth of our planet's atmospheric pressure. Additionally, Luna 9 diligently reported radiation levels, indicating a daily dose of approximately 30 Roentgen. These revelations provided critical insights into the lunar environment, essential for understanding the challenges and opportunities for future exploration and habitation. Beyond passive observation, Luna 9 actively interacted with the lunar soil, conducting a rudimentary but groundbreaking soil mechanics experiment. Using a rod to exert pressure on the moon's regolith, the spacecraft yielded a significant discovery: an approximate bearing strength of at least 0.4 kilograms per square centimeter. This crucial finding hinted at the robustness of the lunar surface, suggesting its capability to support potential future landers and rovers, marking a crucial milestone for subsequent missions. However, as with most missions, Luna 9's expedition had a finite lifespan. Its mission concluded as its batteries depleted after approximately 3 days on the moon's surface. Nevertheless, within this brief window, the spacecraft managed to transmit a total of 8 captivating images, alongside invaluable scientific data. Pioneering missions from Luna 9 to Apollo 11. Luna 9's groundbreaking mission in 1966 marked a pivotal moment in lunar exploration. Its successful landing on the moon's surface opened doors for further endeavors. Following its trail, Luna 13 embarked on its lunar voyage on December 24th of the same year, contributing significantly to our evolving comprehension of the moon. This subsequent mission mirrored Luna 9's objectives, conducting analogous experiments that delved deeper into lunar understanding. Expanding our insights into the moon's nature and characteristics, Luna 13's endeavors in 1966 solidified our groundwork for future lunar explorations. However, the zenith of human space exploration arrived with the momentous Apollo 11 mission in 1969, reshaping our cosmic comprehension irrevocably. The journey commenced on July 16th from Florida's Kennedy Space Center, representing the pinnacle of the ambitious Apollo program's objectives. The mission's primary goal was to safely transport human beings to the lunar surface and secure their return to Earth, a task entrusted to three extraordinary astronauts. Neil Armstrong, the mission's commander, etched his name in history by becoming the first human to set foot on the moon. His legendary strides were followed by Edwin "Buzz" Aldrin, the lunar module pilot, and Michael Collins, who orbited the moon in the command module, while his fellow astronauts explored the lunar terrain. The Apollo 11 mission epitomized a marvel of engineering and innovation, constituting three fundamental components. The command module, aptly named Columbia, ensured the astronauts' safe return to Earth, serving as their sanctuary amidst the vastness of space. Accompanying it, the service module provided crucial life-sustaining resources, including power, oxygen, water, and propulsion to Columbia, ensuring the astronauts' survival. At the heart of the mission lay the lunar module, christened Eagle. This ingeniously designed craft possessed a two-stage structure pivotal for transporting Armstrong and Aldrin from lunar orbit to the moon's surface and, ultimately, effecting their safe return to the command module. The Apollo 11 mission, a remarkable venture, lasted around 8 days, teeming with excitement, marvel, and historic breakthroughs. Departing from Earth, the spacecraft meticulously maneuvered toward the moon's orbit, a pivotal moment achieved by July 19th, paving the way for the subsequent phase. On July 20th, astronauts Armstrong and Aldrin aboard the lunar module commenced their descent, gently landing on the serene plains of Mare Tranquillitatis, popularly known as the Sea of Tranquility. Armstrong's now famous words, "That's one small step for man, one giant leap for mankind," echoed across the globe as he took humanity's inaugural steps on the lunar surface. Aldrin joined him, and for approximately 2 hours, the duo engaged in scientific experiments, diligently collecting invaluable samples, proudly planting the American flag, and setting up crucial scientific instruments. Meanwhile, Collins, orbiting the moon in the command module, conducted his series of experiments and meticulously captured photographic evidence of the lunar terrain. Upon the completion of their lunar tasks, Armstrong and Aldrin seamlessly rejoined Collins on July 21st. Subsequently, bidding farewell to the lunar module, they plotted their trajectory away from the moon's orbit, initiating their return journey to Earth. Their successful re-entry culminated in a splashdown in the Pacific Ocean on July 24th. This historic mission wasn't just a leisurely trip, it was packed with scientific endeavors and meticulous planning. The experiments conducted on the moon's surface were aimed at unraveling mysteries and gathering crucial data. Among the various scientific instruments deployed, there were seismic instruments to measure moonquakes, a device to measure the solar wind, and a laser reflector to facilitate precise measurements of the Earth-Moon distance. These experiments provided a wealth of information, advancing our understanding of lunar geology, the moon's composition, and even Earth's place in the cosmos. Moreover, the collection of lunar samples wasn't just a souvenir gathering exercise. Scientists have extensively studied these samples, analyzing their composition to learn about the moon's formation and evolution, shedding light on our own planet's history. The journey back to Earth was meticulously planned, taking into account the complex dynamics of space travel. The re-entry into Earth's atmosphere was a critical phase, subjecting the spacecraft to intense heat. Engineers and scientists had meticulously designed the spacecraft to endure this fiery ordeal, ensuring the safe return of the astronauts. Reshaping lunar understanding. The accomplishments of Apollo 11 rippled far beyond the tangible feats of landing and exploration. Scientific revelations gleaned from the mission data expanded our understanding of the moon in profound ways. Analysis unveiled that the lunar environment possessed a subtle atmosphere primarily comprised of helium, neon, and argon gases. This discovery challenged previous assumptions about the moon's atmospheric makeup, shedding light on its unique characteristics. The dominant feature of the lunar landscape, the regolith, was a revelation. This fine layer of dust, formed over millennia due to the constant bombardment of micrometeorites, blanketed the moon's surface. Studying the regolith provided invaluable insights into the geological processes shaping celestial bodies, offering a glimpse into the moon's tumultuous history. One of the most intriguing revelations was the absence of a global magnetic field on the moon. This absence piqued scientific curiosity, prompting further investigation. Although certain areas exhibited localized magnetic anomalies, the lack of a comprehensive magnetic shield raised questions about the moon's geological evolution and its stark contrast to Earth's magnetic characteristics. Amidst the predominantly arid lunar environment, traces of water ice were discovered within the moon's perpetually shaded craters. This unexpected finding challenged previous assumptions about the moon's dryness and raised prospects for potential future lunar exploration, fueling discussions about the feasibility of utilizing these resources for sustained space missions. Arguably, one of the most significant discoveries was the estimation of the moon's age at approximately 4.5 billion years. This estimation aligned with prevailing theories about the solar system's formation, bolstering the idea that the moon originated from a cataclysmic collision between Earth and another celestial body. This theory not only explained the moon's formation, but also provided crucial insights into the early history of our planet, emphasizing the dynamic and violent nature of the early solar system. The revelations stemming from Apollo 11's mission data weren't just scientific notches on humanity's belt. They fundamentally altered our perception of the moon, transforming it from a celestial body shrouded in mystery to a scientifically intriguing world ripe for deeper exploration. The journey of Chandrayaan-Three to the moon's south pole. In 2023, the global space exploration landscape witnessed a remarkable milestone with India's Chandrayaan-Three mission. This mission stood out not only for India, but for the entire international space exploration community due to its ambitious objective: executing a controlled landing near the enigmatic south pole of the moon. This region, known for its scientific potential and complexities, held immense promise for uncovering new lunar mysteries. The Chandrayaan-3 mission was characterized by its intricate design and multifaceted goals, featuring 3 crucial components, each assigned specific tasks. The orbiter, a vigilant observer from above, was equipped with 8 advanced scientific instruments. Positioned in a circular orbit approximately 100 kilometers above the lunar surface, its primary role was to meticulously scrutinize the moon's surface and atmosphere, gathering comprehensive data. Accompanying the orbiter was the lander, named Vikram as a homage to Dr. Vikram Sarabhai, the visionary founder of the Indian Space Research Organization. Beyond being a symbolic tribute, Vikram served as a robust workhorse, furnished with 4 specialized instruments. Its mission was to collect crucial data on various aspects such as temperature variations, seismic activities, plasma density, and surface composition, specifically at its designated landing site. The meticulous planning and instrumentation of Chandrayaan-3 highlighted India's growing prowess in space technology and exploration. The mission's focus on the moon's south pole was strategic, aiming to delve into uncharted territories, unravel lunar mysteries, and provide a deeper understanding of this lesser-explored region. The choice of scientific instruments aboard the orbiter and lander underscored the mission's comprehensive approach towards studying the moon's surface, atmosphere, and geology. These instruments were meticulously crafted to capture a wide array of data, paving the way for significant advancements in lunar research. Pragyan, true to its Sanskrit name denoting wisdom, embarked on a journey that unveiled the lunar terrain with meticulous precision. Housing two sophisticated instruments, Pragyan diligently unraveled intricate details about the moon's mineralogy and the elemental composition of its soil, delving deep into lunar secrets. Vikram's Precision Landing Saga. On August 23, 2023, after a series of intricate orbital maneuvers conducted by Chandrayaan-Three's orbiter around the moon, the pivotal moment arrived for the lander Vikram to embark on its audacious descent toward the lunar South Pole. Detaching from its parent orbiter, Vikram encountered the formidable challenge of making a controlled touchdown on the lunar surface, a task akin to navigating a tightrope walk from space to a celestial body. Descending from space toward the moon presented Vikram with a monumental task. Initially hurtling at a brisk speed of 1.68 kilometers per second, the lander meticulously employed its onboard thrusters to decelerate, gradually reducing its speed to almost a complete standstill. However, the challenge extended beyond mere speed control. As Vikram neared the moon, it had to execute precise adjustments to its trajectory and orientation, analogous to a pilot making last-minute corrections during a landing to ensure a safe touchdown for all aboard. Vikram demonstrated exceptional precision in this crucial phase, making calculated maneuvers to position itself between two lunar craters, Simpelius N and Manzinus C. This specific region was renowned for its extreme environmental conditions, with temperatures plummeting to a bone-chilling -240 degrees Celsius. Moreover, sunlight was a rare commodity in this area, sporadically touching the lunar surface due to the region's unique topography and orientation to the sun. Navigating these complexities and challenges, Vikram successfully nestled itself in this challenging terrain, setting the stage for the subsequent phases of its mission. The precise execution of this descent showcased the expertise and meticulous planning of the mission team, highlighting India's capability to orchestrate sophisticated lunar operations, even in the most demanding lunar environments. The choice of the landing site was strategic, aimed at exploring a region with unique characteristics that could provide invaluable insights into the moon's composition, geological features, and environmental conditions. Following its successful landing, Vikram wasted no time. The lander smoothly deployed its solar panels, resembling wings spreading out after a long flight. These panels weren't just for show, they were essential for powering the mission's scientific instruments and ensuring the smooth functioning of the lander. As the solar panels unfolded, Vikram extended its antennas, creating a vital communication link with the orbiter above. This connection was crucial, serving as the lifeline between the lunar mission and the researchers and scientists eagerly stationed on Earth. This real-time communication allowed for the seamless exchange of data, enabling scientists to monitor and analyze the unfolding events on the moon. However, despite these initial actions, the lunar surface mission had only just begun. Like waiting for dust to settle after a gust of wind on Earth, there was a brief period allotted for the moon dust to clear. During this time, the lunar rover, Pragyan, patiently awaited its turn for action. Finally, given the green light, Pragyan emerged from Vikram's ramp with an air of curiosity and purpose. Imagine the rover as an explorer stepping onto an untouched island for the first time. With a fortnight equivalent to a single lunar day, Pragyan had a limited time frame to accomplish its mission. Designed to travel up to half a kilometer from its parent lander, Pragyan embodied autonomy. It was equipped with onboard cameras and sensors, akin to the rover possessing its vision and instincts. These capabilities were crucial for navigating the rocky and unpredictable lunar surface, ensuring that Pragyan didn't stumble over obstacles or become trapped in challenging terrain. Chandrayaan-Three's lunar expedition on a budget. India's Chandrayaan-Three mission ventured into uncharted lunar territory at the moon's south pole, achieving not only historic milestones but also remarkable financial efficiency that astounded many. Operating on a tight budget of just $74 million, this mission demonstrated India's ability to blend cost-effectiveness with advanced space innovation. Delving into the numbers revealed by the former chairman of ISRO, K. Sivan, the total expenditure of the mission amounted to approximately 615 crore rupees, translating to roughly $74 million. Within this budget, expenses for the lander, rover, and propulsion module totaled around 215 crore rupees, while launch services incurred an expenditure of approximately 365 crore rupees. This meticulous budgeting was notably commendable when compared to its predecessor Chandrayaan-2, which, despite an unsuccessful landing in 2019, had a significantly higher budget of 978 crore rupees, or $96.5 million. Contrasting Chandrayaan-3's budget with other international lunar missions starkly highlighted its cost-effectiveness. For instance, Russia's Luna 25 mission, targeting the same lunar South Pole but ending in a crash, had a budget nearing $2 million. NASA's ambitious Viper rover project, scheduled for 2024, was projected to cost a substantial $433 million. China's Chang'e 4, successfully landing on the moon's far side in 2019, carried a price tag of around $180 million. The success of Chandrayaan-3's budget-friendly approach owed much to its compact design. With a combined weight of only 1.4 tons for the lander and rover, it was considerably lighter than many international counterparts. For instance, NASA's Viper rover alone weighed approximately 1 ton. This strategic lightweight design reduced various associated costs, especially those related to launch and fuel. However, weight wasn't the sole advantage. Chandrayaan-3's financial efficiency was also attributed to its prudent use of existing technology. India utilized its GSLV Mk3, the most robust rocket in its arsenal, previously employed in several successful missions. Additionally, instead of starting from scratch, the lander and rover for Chandrayaan-3 were adapted and enhanced from the designs used in Chandrayaan-2. While finances presented a significant challenge, Chandrayaan-3's mission had to overcome various obstacles. Yet its cost-effective approach, innovative design, and strategic use of technology helped it achieve significant milestones within a constrained budget, setting an example for efficient space exploration. Chandrayaan-3's triumphs in perpetual darkness. India's third lunar mission, Chandrayaan-3, was a challenging odyssey, embarking on a journey fraught with hurdles from its liftoff to its ultimate landing. The endeavor commenced with the monumental task of achieving the correct lunar orbit after its powerful GSLV Mk3 rocket propelled it into space from the Satish Dhawan Space Center in Sriharikota on August 15, 2023. However, the journey to the moon was far from a simple sprint. It required meticulous precision. The spaceship made tricky moves using its engines and gravity from Earth and the moon. Getting it in just the right spot around the moon was super important because it set the path for landing. They didn't just want to orbit the moon. They aimed for the unexplored South Pole, thinking it might have ice and other valuable things. But that spot had big challenges: rough ground, crazy temperatures, and maybe communication problems for the Chandrayaan-3 team. Picking where to land was a huge decision. They had to balance sunlight, a safe place to land, and talking to Earth. This decision was vital because it affected if the mission would work and if the rover could explore well on the moon. Then, on August 23, 2023, everyone was anxious for 17 minutes, known as the 17 Minutes of Terror. This was when the lander, called Vikram, had to slow down super fast from crazy speeds to land safely on the moon. What made it scarier was that Vikram had to do this all by himself, without real-time help. It had to decide in split seconds how to move and where to land perfectly. Vikram did it, and this success let the rover, named Pragyan, start exploring the moon. However, Pragyan encountered its own set of challenges. Navigating the moon's dusty and rugged terrain demanded precision to avoid obstacles and maintain uninterrupted communication. Yet the mission's hurdles didn't culminate with the successful landing. Operating on a tight schedule of just 14 Earth days, equivalent to 1 lunar day, both the lander and rover raced against time to execute their operations on the moon's surface. Within this limited window, they conducted experiments, studied lunar soil composition, recorded temperature variations, and gathered invaluable data, all crucially aimed at transmission back to Earth. The challenges faced were multifaceted. Extreme lunar temperatures swung from a bone-chilling minus 180 degrees Celsius to a searing 100 degrees Celsius, posing operational difficulties. Unpredictable communication blackouts added to the complexity, while the constant threat of solar radiation loomed large. Efficiently managing power resources in this harsh, lunar environment emerged as yet another daunting challenge. Despite these obstacles, the Chandrayaan-Three mission persevered, pushing the boundaries of scientific exploration and paving the way for an enhanced understanding of the moon's mysteries. In 2019, as India geared up for its Chandrayaan-2 mission, astrophysicist Neil deGrasse Tyson voiced his enthusiasm and optimism for this significant lunar endeavor. He highlighted the mission's pivotal nature, emphasizing that Chandrayaan aimed to position India as the fourth nation to achieve a successful soft landing on the moon, following the footsteps of the USA, Russia, and China. What distinguished Chandrayaan-2 was its ambitious objective to explore the moon's south polar region, a prospect that resonated with many eagerly awaiting the mission's success. However, space exploration is fraught with challenges and uncertainties. Chandrayaan-2 faced a devastating setback when its lander lost communication during the crucial descent phase, resulting in an unfortunate crash on the moon's surface. The world empathized with India's disappointment, yet Tyson's voice echoed encouragement, highlighting that setbacks in space endeavors are not the end, but rather a catalyst for renewed determination. Now it's time for today's subscriber pick. In a momentous revelation by renowned astrophysicist Neil deGrasse Tyson, India finally found what NASA was hiding on the moon. Tyson shed light on India's groundbreaking discovery at the moon's south pole, uncovering a captivating world with untold secrets. This celestial region, as Tyson eloquently described, holds unparalleled importance, akin to a treasure trove for scientists. Its shadowed craters might cloak water ice, a precious resource vital not just for life sustenance, but also as potential rocket fuel, a revolutionary find. What sets this area apart is the perpetual shadows concealing ice, contrasted by sunlit peaks offering promising spots for harvesting solar power, crucial for future missions. Yet, beyond their utility, the ancient rocks found there are time capsules, preserving the intertwined history of Earth and the Moon. Within these rocks lie concealed narratives waiting to reveal significant chapters of our planetary past. Let us know your thoughts in the comments below. Discoveries amidst lunar challenges. The Chandrayaan-3 mission was significant due to its landing on the Moon's near side, specifically at the Shiv Shakti point, located about 600 km from the South Pole. Unlike China's Chang'e 4 mission, which soft-landed on the Moon's far side, Chandrayaan-3 faced challenges arising from the rough terrain, perpetual darkness, and extreme temperatures of the South Pole. The Moon has a near side visible from Earth, always facing our planet, and a far side, perpetually hidden due to tidal locking. Chandrayaan-3's landing site was on the near side, presenting difficulties due to the rugged and mountainous South Pole terrain, featuring large craters, deep trenches, and steep slopes. Finding a suitable landing site for a safe touchdown posed a considerable challenge. Additionally, the perpetual darkness near the South Pole, caused by the Moon's axial tilt and deep craters, presented challenges for solar-powered missions. Some regions near the South Pole hadn't received sunlight for over 1 billion years, complicating the generation of energy for the spacecraft's operations. Additionally, temperatures at the South Pole could drop to as low as minus 230 degrees Celsius during the lunar night, potentially damaging electronic components and posing challenges in maintaining spacecraft warmth. Despite these challenges, Chandrayaan-3 was designed to last 14 Earth days or 1 lunar daylight period. During this time, the mission made several significant discoveries. The Vikram lander explored the Moon's exosphere and ionosphere. The Moon's exosphere, almost a vacuum, has a pressure of about 0.3 nanopascals, and the ionosphere, energized by sunlight, creates a sparse layer of electrically charged plasma around the lunar surface near the South Pole. The density of this plasma, crucial for radio communication, was found to vary as the lunar day progressed. The sparse plasma suggested minimal potential delays for transmission and navigation systems, essential for future human habitation. A temperature probe deployed by Chandrayaan-Three revealed significant temperature variations just below the lunar surface. At the surface, temperatures reached around 60 degrees Celsius during the day, but dropped dramatically to about -10 degrees Celsius, just 8 centimeters below the surface. This temperature variation indicated that the moon's topsoil acted as a potent thermal insulator, suggesting its potential use for building habitats to shield astronauts from extreme lunar conditions. The mission also detected a potential moonquake using the Instrument for Lunar Seismic Activity. Moonquakes, lasting from seconds to an hour, can occur due to impact events, tidal forces from Earth and the Sun, or temperature variations. The unprecedented detection of a moonquake suggested internal processes within the moon, with scientists proposing theories such as lunar shrinking or internal heating causing magma pocket formations. The Pragyan rover's laser-induced breakdown spectrometer revealed the presence of various elements, including aluminium, calcium, chromium, iron, manganese, oxygen, titanium, and silicon. Notably, sulfur caught attention, as its detection in the moon's South Pole region was unprecedented. The presence of sulfur is significant for understanding the moon's geology and history, and its association with water ice in cold-trapped regions adds to the exploration of lunar water resources, pursuing the hidden reservoirs of water ice. Despite the significant findings made by the Vikram lander and the Pragyan rover during their exploration of the moon, an important discovery, the presence of water ice, remained elusive. Back in 2008, India's Chandrayaan-1 mission detected signs of water-bearing molecules in the moon's polar regions using the Moon Mineralogy Mapper instrument. The data collected during the mission underwent thorough analysis for over a decade. In 2018, scientists used this data to confirm the existence of water ice through 3 distinct signatures on the lunar surface. Surprisingly, despite these findings, the Pragyan rover, like its predecessors, didn't directly detect water ice. Instead, it indirectly identified sulfur, hinting at other possible implications. This leads to the question, where is the water ice that Chandrayaan-1 detected in 2008? 2 possible explanations emerge. Firstly, it's plausible that the Pragyan rover simply landed in an area devoid of water ice. The 2008 study highlighted that ice deposits are unevenly spread across the moon, with concentrations in lunar craters at the southern pole and sparser distribution at the northern pole. Secondly, another discovery from Chandrayaan-3 provides insight. The chased payload on the Vikram lander recorded a significant drop in temperature just beneath the lunar surface, indicating poor heat conduction in the lunar soil. This suggests that rather than on the surface, the best place to search for water ice might be beneath the moon's surface. Chandrayaan-3, with a planned mission duration of 1 lunar daylight time, attempted contact after the lunar night. But unfortunately, no response was received. Despite this, the mission was deemed successful, achieving its primary goal of a soft moon landing and gathering valuable data during descent. The lunar South Pole is recognized as a rich resource area, and India's Chandrayaan-3 has contributed substantially to our understanding of it. Now, India is collaborating with Japan on Chandrayaan-4, aiming to directly observe and explore the elusive water ice on the moon's southern pole using a lander and rover. Thanks for watching, and we'll see you in the next one.